This is 8.5. You can find this on page 261. It's called Identify and Generate Equivalent Algebraic Expressions. Number 1, substitute the given value into both expressions and determine if the expressions have the same value. So evaluate when x equals 6. So we're going to be putting a 6 in here because that's an x, and a 6 in here. 6 squared is 6 times 6, which is 36. We didn't change this one yet, so I'm going to keep writing. 5 times 6 is 30. 36 minus 30 is 6. Now let's look over here. We said it with x equals 6, so we have a 6 and a 6. 6 minus 5 is 1. 6 times 1 is 6. So they do, we're going to circle do, have the same value. B, when the hexagon shown, this is our hexagon, Linda says the perimeter can be found using the expression 4 times s over 2 plus 2s. David says that he can use the expression 4s to find the perimeter. Do the expressions have the same value when s is 8? So we're going to be putting 8 in. I'm going to do this side first because 4 times 8 is 32. 8 divided by 2 is 4. We're going to keep that 8 right there. He just drops down. 4 times 4 is 16. 2 times 8 is 16. 16 plus 16 is 32. This is 32. This is 32. So they do. Okay, we're heading to page 262. Equivalent expressions are expressions that have the same value for all possible values of the variable. Of course, you can't check every possible value. Fortunately, there's an easier way to show that expressions are equivalent. You can use the properties of operations. If you can apply the properties to one expression to get the other, then the two expressions are equivalent. So here are our properties of operations. We have the commutative property of addition. When adding, changing the order of the numbers does not change the sum. The commutative property of multiplication, that's just the opposite of add. It's just like adding, but instead of multiplying. So I can put multiplying in any order. Associative property of addition. When adding more than two numbers, the grouping of the numbers does not change them. Grouping just means your parentheses here if you look at the example. Associative property of multiplication. Just like the addition one, but with multiplication. However, I group them does not change the answer. And the distributive property. Multiplying a number by a sum or difference is the same as multiplying by each number in the sum or difference than adding or subtracting. I like to call the distributive property the friendship property, and I'll show you why in a second. So let's look at number 2 right here. Identify the properties used to determine the expressions. So this first one, we have this. This property is the distributive property because I went from the outside and I multiplied in. 4 times A is 4A. 4 times 2B is 8B. So we're going to write distributive here. Hopefully yours looks nicer than mine. Okay, now we have 3 here. And it does not matter what order that I put them in. If you see this, they flip-flop the order on this and we're still going to get the same thing. So it's commutative. Then we're going to take this A and we're going to multiply it on the insides here. This is distributive property. Four times 4 is 16. So we added inside the parentheses and we got 16. Then we're going to do the distributive property here. So this is equal because they're getting to be the same thing. Let's check out this one. So I'm taking my x and my y out. That's how I have them here. Leftovers, I have 8 and 5. That is the distributive property. 8 plus 5 is 13. So I have 13xy, and the other one was 3xy. That is not equivalent. A triangle is drawn so that starting from the shortest side, each side is 1 unit longer. So I have S, and then S plus 1 and S plus 2. Okay, so this first one, the groupings, you saw that they changed the groupings. It does not matter. That's the associative property. Then they mix the numbers up here, all through here. That when we're adding, that means it's going to be commutative property because I can put adding or multiplication in any order, and I can still get the same answer. Okay, I grouped it differently. This is associative. I get, we put all those S's together here. This is distributive. So we have 1, 2, 3 S's. 2 plus 1 is 3. So 3S plus 3. Let's look at 4. Are the expressions 6W plus 3Z plus 4W plus 7Z and 8 in parentheses X plus Z equivalent? And the expression 6W plus 3Z plus 4W plus 7Z. The terms 6W and 4W are like terms. They are like terms because they have the same letter at the end. And the terms 3Z and 7Z are like terms. We can add like terms together. This first one, so we started here, and then they changed the order. So this is the commutative property of addition. Then we took the W out here, and they took the Z out, so all we have left is 3 and 7. This is distributive property. So 6 plus 4 is 10. 3 plus 7 is 10. So my letters I have are WZ. This is distributive. So they are not equivalent because this has a 10 on the outside, this has an 8 on the outside. Let's take a look at the check understanding. We're at the bottom of page 263 for those of you following along. Okay, I'm going to rewrite the first expression to determine whether the expressions are equivalent. So 8 and 4, a number that can go into both 8 and 4 is 4. When I take the 4 out, I have 2 left over here, so 2x plus y. And I get 4, what I'm looking for is 2x plus 1. So this is different, not equivalent. When you do an equal sign with the slash through it, that's not equivalent. Okay, I'm going to do the distributive property here. This number on the outside is going to become friends with the numbers on the inside. 3 times k is 3k plus 3 times 3 is 9. 3k plus 9 here, 3k plus 9 here. That means those ones are equivalent.